Last week, you have learned about the OTSU method, how you're able to determine threshold value, global threshold value automatically by using the OTSU formulation. So you have two methods, which is the within class variance and between class variance. So today I will cover up the next chapter, which is the local method or adaptive method. But first thing first, I will show you how you're able to implement global threshold using also under the Matlab platform. And then later on, I will show you in some case where the global method based on also will fail to handle, in which we need to rely on the adaptive method. But first thing first, we will use the Matlab platform in order to show you how the OS works. So basically for this example, I will use the image that was uploaded in your online directory. So in this case, I will show you the thcase1.jpg image, how we're able to do the segmentation process using the OTSU. So first step is we need to upload the image into the Matlab workspace. So you can do that thing by using the imread command, and then you just need to plug in the name of the image. In this case is case1.jpg. So once that thing was uploaded, so you can see this is the dimension of the image, which is 3072 times 3840 times 3. So this is the RGB. So the next step is that you need to convert this image to grayscale representation so that you have the image in one dimension stage, which you can use later on to determine the outcome. So for this case, I will use the subplot to plot the thing. So subplot is subplot starting, this is the y dimension, this is the x dimension. So we use in y row, and then we have the 3 columns. So for the first part of the column, so we will plot the image of j. So you can plot that thing by using show j, and then we put the title as original image. So in this case, you have this image. We have uploaded this thing and then plot the thing in the subplot. So the next part is we need to plot the histogram. So we can do that thing easily by using the same command, which is subplot number 2, which is to the right side. So for number 2, we will upload the histogram. Histogram is imhist command of the j, and then we put the title. We put the title as histogram of this image. So once you upload that thing, you will have the image and its corresponding histogram. So in this particular case, this problem can be solved easily by using the global method. So the next part is how we're able to use the OTSU. So to determine the OTSU or the parameters of the threshold, we can use the command that is known as graythres, which is the gray trace. So gray trace, you need to plug in the grayscale image in order to determine what is the optimal output by using the OTSU. So in this case, we just need to put the J. So eventually you will have this value. So this is the floating point value. If you want to determine the exact pixel, so you need to times this value with 255, so that way you have 164. So 164, if you look at your histogram, 164 is around this side, which is near the valley, in order to segment the image. So the next part, you can utilize the also method in order to determine the output of the binary image. Binary image is BW. We use the command im to BW image to binary. So what you need to put is you need to put the image that you want to threshold, which is in this case is J, and then the level. Levels means that what is the outcome that you determine from the OTSU. So in this case we have JB level. So basically BW is our binary image, and then we can plot that thing by using the same command, which is the subplot, but in this case subplot the number 3 most right side. So we put here is the im show of BW of the binary image, and then title is OTSU threshold with the value of 164. So basically once you plot that thing, so this is actually the output or the outcome once you use the OTSU method to threshold this incoming image. So it's quite easy, it's quite straightforward, and it's quite fast to determine the output of the binary image by using the OTSU method. So this is basically the global threshold methods. So however, if you try to solve the problem in which the illumination is non-uniform by using the OTSU method, so you will have a different outcome. So we try to use in this case is TH case 3. So let's clear everything. So you can clear everything by using the clear all, and then close all will close all the open figure, and then CLC will clear the command window, so everything will clear up. So we start with the fresh of the case 3 image. So first thing, the same thing, we upload the image of th case 3.jpg. Okay, so you can see this is the dimension of the image 510384 with the one dimension only, so it's already in the grayscale notation, so you don't have to transform that thing, the image, to the grayscale. So the next part is, okay, we use the same subplot command. Subplot 13, number 1 is I, so the title will be original. Okay, next we plot the histogram 132 im his of the I of the histogram. So you can see from this thing, from the histogram, the distributions is quite hard for you to determine the distinct value from the two peaks. So you can see from here for the image, this is the overshadow area, this is the overexposed area, this is the underexposed area. So if we try to use OTSU to solve this problem, so we can use the same command, which is level is gray threshold of image I. So for this case you have 0.566. So if we multiply the thing with 255, so also will give an outcome of 1 for 1. 1 for 1 is somewhere near here, which is not really in the value. So let's try to determine the output. So the same command bw is im to bw image of I with the same level. So you have the output of the bw. So let's plot that thing 133. im show bw, the title will be also 1 for 1. So if you see the outcome of the also based thresholding method, so this is the input with its corresponding histogram, so you will get this output. So for this case, it's quite hard for you to distinguish between what is the foreground and what is the background area. So this is the case in which we need to rely on the adaptive threshold methods in order to determine the corresponding output properly. So I will show you some example that I have coded for you to show you how the adaptive threshold works, so that you can appreciate the algorithm. So this is the original image. We use the same histogram. So this is based on the global also method. So when we use the adaptive threshold, so you can see here the image is quite nice, in which you're able to get the text, which is the foreground, and then you're able to distinguish the background for this case. So later on I will show you the theoretical aspect of the adaptive method and how we're able to use the adaptive or local thresholding method to solve the non-uniform image illumination problem.